Hello, engineers. If you want to become an embedded systems engineer, don't start with random tutorials. Start with understanding how real electronic products are actually built in production. Because embedded engineering is not about blinking LEDs, it is about building reliable devices that work for years in the real world. Today, I will give you a clear roadmap, the same path followed inside real IoT product companies. Step 1. Understand electronics like an engineer, not a student. Before writing firmware, you must understand how current flows in a real circuit. Learn concepts like power rails, voltage regulators, pull up, pull down resistors, MOSFET switching, signal conditioning, noise and grounding. Because firmware engineers in production constantly debug hardware behavior. If your sensor gives wrong data, it is not always a software bug. Sometimes it is ripple, sometimes it is grounding, sometimes it is power sequencing. This is where real embedded engineers are different. Step 2. Master microcontroller fundamentals. Now you move to the brain of the system, the microcontroller. Pick one platform like STM32 and go deep. Learn GPIO, timers, ADC, DAC, UART, SPI, I2C, interrupts, low power modes. But don't just learn registers. Build small real-life use cases. For example, read temperature sensor, control motor speed. Build battery monitoring system, create sleep-wake firmware. This builds intuition about how firmware interacts with physical world timing. Step 3. Learn real firmware architecture. Most beginners write code inside while one loop, but real products use structured firmware design. You must understand state machines, event-driven firmware, RTOS concepts, task prioritization, memory management, watchdog recovery. Because in production devices, firmware must run continuously for months without crashing. Embedded engineering is actually reliability engineering. Step 4. Understand sensors, actuators, and interfaces. Real devices interact with environment. So you must know how sensors generate signals, calibration techniques, filtering noisy data, driving relays, motors, displays, EMI, ESD protection. This is where hardware and firmware truly merge. This is the zone where you stop being a coder and start becoming a system engineer. Step 5. Learn connectivity and IoT layer. Modern embedded engineers are not just firmware writers, they build connected devices. So learn MQTT, HTTP, BLE, Wi-Fi, device provisioning, OTA firmware updates. Because today's embedded product is incomplete if it cannot communicate with cloud or mobile apps. Step 6. Build complete device to cloud projects. This is the most important step. Don't just build development board demos. Build full systems like Smart Energy Monitor, Remote Health Device, Industrial Data Logger, Smart Agriculture Controller, where you design hardware, firmware, backend, dashboard. This makes you extremely valuable in industry because companies don't hire tutorial experts, they hire engineers who can ship products. Final advice. Embedded systems engineering is a slow mastery field. It rewards patience, curiosity, and deep debugging mindset. If you stay consistent for 2 to 3 years, you can become an engineer who builds real connected devices used by thousands of users. And that is a very powerful skill. If you want more real-world IoT engineering insights, follow this channel. I share how production embedded systems are actually designed from device to cloud. See you in the next video.